Alright, today we're going to start our last unit, which is on exponentials and logarithms. So let's first explore what an exponential equation is. So you're going to read through the following situation and answer the questions that follow to learn about exponential equations. Zombie apocalypse. Recently, there has been an outbreak of a deadly virus in Illinois. Sources say it came from a passenger traveling through O'Hare Airport. When infected, the virus turns people into zombies. People become infected when bitten by someone with the virus. Currently, each zombie can infect 3 new people every day. If 5 people were initially infected, complete the table and graph below to show how many total zombies there will be every day for the first 10 days of the attack. Alright, so we need to fill out this table with the information that we were given. What it's saying is that every zombie can infect 3 new people. So if we start with 5, we're going to take 5 and multiply it by 3, because that's each zombie can infect 3 more people, spreading the virus. So 5 times 3 is 15. That's how long it takes for day 1. Doing it again, now those 15 can multiply by 3, and they're going to infect, and now we've got to 45. Multiplying by 3 again, you get 135. Keep going with the cycle. Times 3. So by 4 days, there's 405 zombies. Times 3 more. Times 3 again. So if you look at that, on day 1, in the initial outbreak, there were 5 zombies, and we multiplied by 3 for each successive day. And look how fast that zombie population increases, getting almost into the 100,000s by day 10. So let's take a look at the graph of this data. On the x-axis, that will be our days. So that's easy to number. That's 1 through 10. On the y-axis, it's not as easy. And for the numbers that are this large, we probably should go by 25,000. This is the number of people that are infected. So on the side, I'll write number infected. So the first day we had 5. So that's going to be right there on the y-axis and not very high at all because we're going by 25,000s. 1 is 15. That's also going to be pretty low. 2, 45. Again, we're not really moving up. 3, 4. Finally, by the time we get to day 5, we start to go a little bit higher into the thousands. Day 6, 7, we finally are moving up into 10,000s. Day 8 now, we're above 25,000. 9, we jump up to 98,000s. We're closer to 100,000. And then by day 10, we're not even on the graph the way it works. So we can see the shape of this graph. So let's answer the questions that follow based on the data below. How many zombies or humans are turned into zombies on day 10? On day 10, it was 295,245. Could we find that number for the day 7? You could. How would you find it? You would multiply by 3. Multiply day 10's by 3. So whatever day 10's answer was, let's take that and multiply it by 3. 885,735. So which equation represents the model of the zombies that are turning into, that are being turned into, or the number of zombies turned each day if you start with 5 zombies? So that's 3 choices. Let's take a look. Let's graph each of them and see which one matches up with our graph. If I go to y equals and I clear out whatever's in there, okay, the first equation is 3x plus 5. Graphing it, hopefully now you can see that that's a linear equation. So I know it can't be this one because my graph was not a straight line. Let's try the next one. 5x to the third. If you graph that one is a snake shape. That's the cubic shape that we worked on. So it's definitely not that one. Let's try that last one. That one says 5 parentheses 3 to the x. Okay, so I'm seeing more of that J shape. Let me hit second table and see the numbers. Take a look at your numbers compared to your table. 0 goes with 5, 15, 45. So I think we found the equation based on what we're doing here. And here's another way you could have found that what happened, how many there were on the 11th day. So this is the equation. This is a new type of equation. When we graph it, here's a zoom fit version of it so you can see that J shape that it makes there. This is called your exponential equation. So let's take a look at how we use these and how they're applicable to your actually everyday life. So this is called an exponential equation. The general form of an exponential equation is y equals ab in parentheses to the x. A is your initial value. It's whatever you start with. So in our problem, it was the 5 zombies. That's what we started with. B is the rate of change. So that's what you're multiplying by each time. And x is your unit of time. So it could be days, it could be years. Generally, we're going to look at years. So here's the equation in our problem. Y equals 5, parentheses 3 to the x. What did each value mean in this equation? 5 was the initial number of people infected. Number of infected people. I should say initial. That's the very first. So 5 people were initially infected. 3 was the rate at which you could infect others. I'm going to say the rate of infection. And x in our case was number of days. So it's important to understand how to use those terms and the numbers in the equation so that you're using the equation appropriately. Because if I ask you to use the equation instead of the table and the graph to find how many zombies were there after 11 days, you should be able to do that now. Because I know that x stands for time, so I'm just going to replace the x with the 11. And if I use my calculator, I can see I get that same answer again. 885,735. Okay, let's try it again. This time, let's see if only one person was initially infected. What would the table and the graph look like and the equation be in this case? So it's still going to be the same number of the rate of infection. They can turn people 3 times a day, or 3 people a day. So 1 times 3 is 3, and I'm just going to keep going on with my table. 9, 27, 81, 243. I think it's 729 comes next. 2187. Alright, so when it's only one person initially, it's a much different graph and table. So just changing that one value dramatically changes the number of people that get infected. So this time, instead of going up by 25,000, I think I can go up by 5,000 this time. Alright, so same idea. The graph starts low, doesn't really change much. Getting a little bit higher every time you go along, until eventually, by day 8, we finally breach on our graph. So how can I make an equation for this? We know it's going to be y equals, and the formula is a b to the x. So for our equation, a stood for the initial value. So what was the initial value on the very beginning, the number of zombies we started with? It was 1. What were they increasing by each time? We were multiplying by 3, and then x is the unit for time. So there's my equation, and we can check it by using our calculator, second table, and see if those graph and numbers match up. So 0, 1, 1, 3, 2, 9, you can see it matching up as you go through. So towards the end of the class, we'll look at, when you look at Hollywood movies, do they portray these situations with zombies in Hollywood as realistic? And we'll watch this link at the end of class, once we've got some more practice with it. But let's look at some practical problems, because obviously we're not going to be worried about zombies anytime soon. What this is really useful for is with money, because we use exponential ideas with money and investments. So one major example of exponential growth deals with money. Consider the following situation. Sterling has $300 to deposit into an account at 6% interest compounded annually. Given the exponential equation, y equals 300, parentheses 1.06 to the x, fill in the table. So let me put in that in my calculator. 300 1.06 to the x. Second table. So let's fill in those numbers. 300, 318, 337.08, 357.30, 378.74, and 401.47. In this question, where does this 1.06 come from? So we know that this is the b value in our equation, that's what you're multiplying by. But why is it 1.06? I know that 6%, if I turn that into a decimal, is 0.06, because if a decimal turned into a percentage, you just take the number divided by 100. So where does 1.06 come from? 1.06 comes from the fact that if you take your initial value and you multiply it by 1.06, that adds in the interest that you earn on your investment. So if I take 300 and I just multiply it by 0.06, it's $18. What putting the 1 in front of it does is it adds it back into your original value. So this is kind of a tricky concept, but we're going to keep working on this. That's where that 1.06 comes from. It's the rate So how much money will Sterling have in 20 years? We can use our table for that, or the equation. In 20 years, he'll have $962.14. So now try that bottom question on your own.